right-hand slope is very similar to the left-hand slope, and it is governed by this formula here. The right-hand slope is the line just between C and B, which is this bit here, as shown in the formula by the fact that it's between C and B. Let's look at a quick example. A company knows the cost of a project is going to be between $30,000 and $60,000, with the most likely cost being $40,000. What is the probability that the project costs more than $50,000? Now this is the diagram we had for last time, but what we're going to do is we're just going to redraw it slightly, just to make it slightly clearer. The triangle distribution doesn't always have to follow exactly the shape where the point is on the right hand side. The point can sometimes be on the left hand side. So we know our minimum value is 30,000, the maximum value is 60,000, and the value that is most likely to occur is 40,000. We want to know the probability the project costs more than 50,000, so that's going to go in here. Now again, the probability we want to find is always the area, so we'll colour that in. So again, the first thing we need to do is we need to work out the height at this point. Now the height is based on this formula here, and it's going to be 2 brackets, now B is 60,000 minus X, which is 50,000, over B minus A and B minus C. If we grab our calculator, we can work this out by just typing it in. Again, it's best if we write this as a fraction, so if we press the fraction to decimal button, we see that this is 1 over 30,000. Now that we know the height, we need to work out the area. Now the area of a triangle is just a half times the base times the height. Now we know the height is 1 over 30,000, and the base is just the width here, which we can see is 10,000 times 1 over 30,000 gives us 1 over 6. So that is the answer to part A. Question B asks, what is the probability that the project costs less than 50,000? Now we know probabilities always add up to 1, so the probability for B is just going to be 5 over 6.